So my talk is primarily a response to a recent paper by Julian Mercy and Lorenzo Rossi, who are both here. Thanks again, guys, for coming to this. Their paper is called Generalized Revenge, and last I checked, it was forthcoming. Has it been officially published yet, or is it still forthcoming?
So, yeah.
It's officially
yeah.
out? Okay, at AJL, right?
AJP.
AJP, okay, sorry, okay. So let me set up my screen share here. Can everyone see my screen? Yeah, okay. Great, so their paper is introducing a family of revenge paradoxes for each of 4 different subclassical approaches to semantic paradox. And so I'm going to kind of respond and address, suggest certain ways you can try to get around these new family of paradoxes. Before I say more, let me just kind of situate us in this sort of discussion around semantic paradoxes. So I take it we're all familiar with the phenomenon of semantic paradox, given that we have the ability to generate self-referential sentences and that we have a transparent truth predicate. We can create a sentence that says of itself that it is not true. And just having that sentence around will trivialize classical logic, which means that we can prove anything from it. And so very broadly, you have 3 ways of avoiding this result. One is to, in some way, restrict self-reference, restrict the truth predicate, or weaken the classical logic. And so when I say subclassical solutions, I just mean one of the ones that chooses to weaken the classical logic. I take there to be 5 basic categories of ways of doing that, corresponding to the 5 rules that you need to get the result of triviality in the first place. The last of these listed here, the reflective approach, hasn't gotten as much attention as the other 4. And I won't really be talking about it much in this talk. In the Mercy and Rossi paper doesn't talk much about it either. But basically, the benefit of going with one of these is that you get to keep your naive truth rules and you don't have to place any restriction on self-reference. So by the way, just throughout, these are the little acronyms I'm going to be using kind of for these general approaches. I'll say more about what exactly I have in mind as corresponding to these different logics as we go forward. So here's, as I understand it, Mercy and Rossi's revenge argument in a nutshell. The K3 and AL approaches cannot express the thought that some sentence phi is paradoxical, whereas the LP and ST approaches cannot express the thought that some sentence phi is unparadoxical. This argument is generalizable to any viable subclassical solution. And in particular, and very importantly, presumably the reason we want to go to a subclassical approach is because we want to have a naive truth predicate. And they argue the reasons that would motivate you to want a naive truth predicate are of a kind with reasons you have to want to be able to express paradoxicality and unparadoxicality. And so if you can't express those when you go to these subclassical solutions, you're not really satisfying the motivations that brought you there in the first place. And so we just need, in order to not be ad hoc, we just need to accept that actually, look, we can't, we have to just give up on this dream of being able to have all of these naive predicates. And so what I'm going to try to argue in a nutshell is just that given varying degrees of caveat, these 4 target approaches can express the notions of paradoxicality and unparadoxicality. So we won't have to give up on naivety, at least not for these reasons. And a general theme is going to be the thought that we can express these things. The predicates that express them are going to behave non-classically But that's okay. It's not going to bring greater costs than the costs we already paid when we decided to go for these non-classical approaches to begin with. Okay, so this has been sort of by way of introduction. The structure of the talk is first I'm going to present the paradoxes that Mercy and Rossi give. And then I'm going to offer alternative ways of expressing the notions of paradoxicality and unparadoxicality for these approaches. And then to whatever extent I still have time at the end, I'm going to address what I consider to be the most serious and interesting objection to the general approach I'm taking, which is a kind of objection of the sort that is, all I've really done is change the subject. Okay, so I'll be working following Mercy and Rossi with a single conclusion sequent calculus. So I take it, we're familiar with these kinds of rules. The only sort of point to make is since we want to be able to work with non-contractive approaches, the antecedents of these sequences will be multisets, which means they can have multiple occurrences of the same formula. And so just going to list the rules that we kind of will be starting with. So these are the structural rules and hopefully familiar negation, conjunction, disjunction rules. Notice, by the way, this little double line here for the double negation rule just means you have the rule going both ways. Implication rules, and then a bottom elimination rule. That is what it's going to allow us to prove anything from a proof of bottom. Okay, so, and then there's also De Morgan laws, but they won't really be involved in what I'm doing here. So basically, you start with all the rules I just showed you, and you have your classical logic, and then dropping certain rules is what's going to give you the 4 subclassical approaches that we'll be working with. So if you drop the introduction rules for negation and conditional, you get K3. If you drop the elimination rules for those instead, you get LP. For ST, you drop cut, and you drop all the elimination rules that involve more than one premise. So that's negation, conditional, and disjunction. And then for AL, you drop structural contraction, and you replace the disjunction elimination with this weakened version. I should say Mercy and Rossi work specifically with Zardini's version of a non-contractive approach, but they claim, and I have no reason to doubt, that their sort of result generalizes for non-contractive approaches in general. Okay, now also crucial to their paradoxes is the notion of classical recapture relative to some set of rules or sequence. And so what this notion is that a theory satisfies classical recapture relative to some set of rules or sequence if and only if, for any sentence in that theory, if it satisfies the rules or sequence in the set in question, then it satisfies full classical logic. So in case that's confusing, I think it's helpful to just kind of run through the examples. So in the first case, we've got LEM classical recapture. So a theory just satisfies LEM, just has the property of LEM classical recapture, just in case any sentence, if it satisfies LEM, it will satisfy all of classical logic. And so what Mercy and Rossi show is that if you start with K3 and you add these weakened versions of the 2 rules that we dropped to get K3, then closure under all of those rules will guarantee LEM classical recapture. Meaning if you have closure under all of those rules, then any sentence that satisfies LEM will satisfy full classical logic, meaning it will be closed under the full strength negation, introduction, and conditional introduction rules. And they prove an analogous result for ECQ for LP. So if you start with LP and you augment it with these weakened versions of the rules that we dropped, then any sentence that satisfies ECQ will satisfy full classical logic. And then for the AL approach, if you replace structural contraction with this weakened version, then you have classical recapture relative to the law of contraction. So that's if phi, then phi and phi. And then finally, for the three rules we dropped besides cut in ST, if you replace them with these weakened versions, then any sentence that satisfies cut will satisfy the full strength version of these rules. And so throughout, we'll be working with the initial logics augmented with all of those, with the weakened rules. And the idea is that allows us to guarantee that we have the recapture property. Now, the original logics, as I understand, are already closed under those weakened rules, but if we actually add them to the logic, we guarantee that we keep the recapture property. And so that if we then extend the logics, we can guarantee that any extension will have the recapture property as well. In particular, if we were to extend the logics in a way that would give us triviality if we also added the recapture rules, but didn't otherwise, that would tell us that we can only add this extension on pain of not being able to keep the recapture property. And then the last thing is to these four, we'll also be adding just the naive truth rules. And so with all that together, that allows us to now get the paradoxes that Mercy and Rossi introduced. So here it is for K3. You start with K3 augmented with the recapture rules and the truth rules, and then also add these two rules here. The result is triviality. And the idea is that these rules, according to K3, give the meaning of being paradoxical according to K3. And so there's some intuitive force to this. If you have a sentence phi and phi or not phi entails bot, then that would seem to imply that phi is paradoxical. And then for an elimination, if you have the phi is paradoxical and then you also have LEM for it, I mean, given how we introduced paradoxical, that would give you, allow you to derive bot. Similar rule for LP, but now working with unparadoxical. So the idea is if phi satisfies EC2, then it's unparadoxical. And then a similar kind of elimination rule that mirrors the introduction rule there. Moving on to the AL, we have a similar kind of introduction rule where it's the law of contraction entailing bottom that tells us that phi is paradoxical. But here with the caveat that when you introduce that phi is paradoxical, you discharge all instances of the law of contraction for the phi in question from the antecedent of the premise sequent. And then again, the sort of the elimination rule that you would expect with just the caveat that however many instances of the law of contraction you need to derive that phi is paradoxical, you need to add at least as many to the antecedent of the conclusion sequence to be able to derive bot. And then finally for ST, we need a little bit sort of new machinery, and that is to have to introduce rule assumptions that we can discharge. So the idea here is if you introduce as a rule assumption that you've got phi and also that phi entails psi, and from that you can prove a sequent with conclusion or consequent psi. And also you need those to be able to prove that. So that's what the little boxes tell you next to the rule assumptions, is that you can't discharge these vacuously. What that would seem to tell you is that you can, given those assumptions, cut phi. And so since according to the ST way of viewing things, what being unparadoxical amounts to is that you can cut phi, that allows you to infer that the phi is unparadoxical and allows you to discharge the assumptions that you used to get there. And then the elimination rule is again sort of what you would expect. If phi is unparadoxical, then give the obvious other premises, you can go ahead and cut phi and get the result of that. Now, all four of these, when augmented with these rules, are trivial. And so Mercy and Rossi's argument, as I understand it, in a bit more detail than I gave it before, is as follows. In order to be viable, these non-classical approaches, and when I say non-classical approaches, I mean the logics when augmented with truth, since we're just assuming that the reason we go to non-classical approaches in the first place is that we want to keep the naive truth predicate. So to be viable, the non-classical approaches have to satisfy the appropriate form of classical recapture. They also have to be able to express the thought that phi is paradoxical and that phi is unparadoxical. That the rules that Mercy and Rossi give is how you do express those thoughts. And finally, that the non-classical approaches can't, on pain of triviality, adopt both the recapture rules and the paradoxicality and unparadoxicality rules. And so the conclusion is just these approaches are really not viable. Now, I don't think there's really any hope for rejecting this last fourth premise because Mercy and Rossi prove it. I think you can find various ways of trying to get around the first three. I'm not going to go into, so in this next slide, I just sort of tried to come up with various ways you might try to question them. I'm not going to go into them just in the interest of time. I'll just say I think some are more maybe promising or worth exploring than others, but I'm just going to explore the option of saying, no, actually, there are other ways of expressing paradoxicality and unparadoxicality. So I'm going to accept all the others, at least for the sake of argument, and say that it's this third one that can be rejected. Okay, so now for the rest of the talk, what I'm going to do is propose alternative ways of expressing these concepts according to these approaches. And then at the end, I'm going to come back to address Mercy and Rossi's motivations for choosing the rules that they choose. So a kind of motivating thought for a lot of what I'm going to do now is that it seems prima facie odd that Mercy and Rossi need to appeal both to paradoxicality and unparadoxicality to trivialize these non-classical approaches. And the reason is, I mean, it seems they need both because for any one of them, it seems to only really have trouble expressing one, not the other. And so you might ask yourself, well, then why don't you just, keep the one you can express and just use negation to express the other one? I mean, aside from maybe helping you to avoid these paradoxes, this would also just reduce the number of primitives, which presumably would be a good thing. So that's the kind of general thought I'm going to explore and see what comes of it when applied to the four different approaches. So here's the thought applied to K3. So with K3, the problem was paradoxical. So it's okay, let's see what happens with unparadoxical. And a simple thought is just, according to the K3 worldview, a sentence is unparadoxical just in case it satisfies LEM. So that just suggests sort of very simple and straightforward rules that basically just say that satisfying LEM is just equivalent to being unparadoxical. And then you can just define paradoxicality as the negation of unparadoxicality. And for LP, you do the exact same thing, right? You say, according to the LP way of seeing things, a sentence is paradoxical just when it's inconsistent. And so you define paradoxicality accordingly, and you say that unparadoxicality is just a negation of that. Now, one thing you'll find if you take on this approach is that, let's talk about K3 for a moment. If you take the rules I proposed and define paradoxicality as just a negation of unparadoxicality, you can very easily just derive the introduction rule, the elimination rule that Mercy and Rossi give. But without the full strength negation introduction, you can't derive the introduction rule. So this is how you would do it, and the dotted line is kind of where you would need negation introduction. I mean, I should say I don't have a proof that you can't derive their version, but just it doesn't seem that you would be able to. And if you tried to use, instead of negation introduction here, the weakened version we got from the recapture rules, that would not, as far as I can tell, suffice to rescue Mercy and Rossi's proof of triviality. And with LP, you get exactly the dual situation, which is what you would expect. So you do get you can derive their introduction rule. But in the absence of full strength negation elimination, you don't get the elimination rule for unparadoxicality. Now, just based on what I've said so far, what this seems to me to intuitively suggest is that the rules I've proposed are very similar to the ones they proposed, and theirs are just a bit stronger. And that bit of extra strength kind of builds in, in the case of K3, it builds in a kind of negation introduction-y reasoning into the notion of paradoxicality, kind of forces it to behave in accordance with it in a way that you might think is not in accordance with just the K3 approach, and analogously for LP. To strengthen this intuition, consider again the unparadoxicality rules that they give for LP. So if you look at this top rule, the introduction rule, it looks a lot like just negation introduction, like a special case of negation introduction. In particular, the sort of introduction condition for having that phi is unparadoxical. It's just the same introduction condition for having not phi and not phi, which is what I proposed was just equivalent to being unparadoxical. So if you take that thought, right, that unparadoxicality just has the same introduction condition as not phi and not phi, and when you then notice the appearance of unparadoxicality in the elimination rule, you plug in instead the thing that has the same introduction condition, namely not phi and not phi. What you see is that the elimination rule is just a special case of negation elimination. It's just a way of making it that from phi and not phi and not phi and not phi, you can entail bot. And the thought is that just seems to be, that's just something an LP theorist wouldn't accept given the LP approach. Now, another thing I want to sort of briefly go over is just that now, in light of everything I said, it should be also clear that it didn't really matter what primitive I took. So if you accepted the rules I gave, there's no reason not to take the negative versions as well. And that should just make it clear that really, whichever way you decided to go with the primitive, what I'm really just proposing is that we take paradoxicality for K3 as being equivalent to a negation of LEM, and unparadoxicality for LP as being equivalent to the law of non-contradiction, or an instance of it. So now, there's something intuitive about this, which again, it just seems to match the K3 and LP sort of worldview. But it should also seem, if you know K3 and LP, you should know that it's also going to give you weird and unexpected kind of results, because in K3, you don't get to have negations of instances of LEM. And so for no phi is it going to be the case that phi is paradoxical. And for LP, the law of non-contradiction is valid. And so it's just going to be the case that for every phi is unparadoxical. In particular, in K3, you're not going to be able to say that the liar sentence is paradoxical. And in LP, you're going to be able to say that the liar is unparadoxical, both of which should seem weird. And so as a general point, it seems like K3 is undershooting and LP overshooting. Now, I think just as far as this is concerned, that LP is in a better situation than K3 for the following reason. It's just that LP can at least express the result of this overshooting. It can just say, yes, the liar is unparadoxical. Whereas for K3, you can see that the result is that the liar being paradoxical won't hold, but you can't really express that from K3. And also just if you kind of extend these logics in order to be able to make claims like, everything is unparadoxical or nothing is paradoxical. In LP, you'll be able to just say that, whereas in K3, you won't. So with all this in mind, I would say the following. given what I've suggested, both of these are better off than they are with Mercy and Rossi's rule, because at least we're not in a trivial situation. But I still think K3 is worse off because of what I just explained. And so that for K3, really the better option is that we say, this is expressively impoverished, and you do need to find some way of extending K3 in order to be able to express a notion of paradoxicality. But I guess the only thing I would say is that in light of everything I've just said, it seems like this maybe is just a familiar problem that we've known about for a while of K3's sort of inability to express effectiveness. And it's one that, whether you agree with those approaches or not, people have tried to solve, as in, for example, the Hierarchies approach in Saving Truth. With LP, on the other hand, I think that the right thing to say is that you should just bite the bullet and accept that everything is unparadoxical, that that's just a surprising result that we learn from doing some logic. Now, Graham has a kind of alternative way of dealing with this, but just in the interest of time, I'm actually going to skip it and just say, if anybody wants to talk about this in particular, I'd be happy to come back to it in the Q&A. I have some stuff here about kind of faithfulness to English objections to saying that everything is unparadoxical in LP, but I'm gonna skip that in the interest of time and move on to the AL approach. So this sort of strategy I've worked with so far, which is essentially to say, look, flip the primitive, and instead of using entails bot to define these things, just use regular old negation, and then the fact that one of the negation rules is blocked will block a kind of just reduction to the rules that Mercy and Rossi had. It's not going to work with AL, because with AL you still have full strength Boolean negation. So I kind of go through here what those rules would be, and it's fairly straightforward to show that, yeah, you do just get you can just derive the same intro and elimination rules that they have. So for AL, I mean, you can say something like what I just said for K3, which is something like, look, we just need to extend this in order to be able to express paradoxicality. And in fact, there's much greater urgency because here we're still in a trivial situation. But I think for AL, there's a better option. So recall that the introduction rule that Mercy and Rossi give is one that when you introduce that phi is paradoxical, you discharge every instance of the law of contraction from the antecedent of the premise sequence. Now, if you deny that, if you just remove the multiple discharge part of the introduction rule, that blocks the proof of triviality. And so I think that's what a non-contractivist should say. A non-contractivist should say, look, asking us to do that multiple discharge is in effect kind of building in a structural contraction, asking us to contract out all those instances, but we're in a non-contractive setting, so there's no reason to do that. Mercy and Rossi do consider this line, and what they say is that this is going to involve having a hierarchy of notions of paradoxicality, kind of depending on how many instances of the law of contraction for the phi in question you need to entail phi. But I think that here, so they argue against having a hierarchical notion like that. And I agree, sort of, they argue for that kind of on philosophical grounds. And I think those arguments are right. But I think the non-contractivists can just hold their ground and say, no, look, there's just one notion of being paradoxical. You introduce it when you can prove from the law of contraction for phi that bot. And if you've got other instances of that law of contraction, you don't get to discharge them. You would if we had full structural contraction, or maybe you could argue if phi were unparadoxical, but that's not the case here by stipulation. And so there's no reason to think we can discharge all of them. And one thing I like about this response is that it sort of mirrors what I said earlier about the K3 and LP responses, which is that it seems like the very rule that we went to this logic to leave behind has been kind of built into the notion of paradoxicality, and that's what's getting the result. Okay, moving on to ST. Since ST doesn't come with the full strength Boolean negation, the strategy of kind of switching the primitive looks promising again. So here are the rules that I'm offering for paradoxicality for ST. I will say this is somewhere where I'm really not very sure. So I'll explain why I'm going for these rules, but I'm still not really quite sure that they work. So I'm curious if people have thoughts about it. But for the introduction one, the thought is, you know, if you've got here gamma 0 entails phi and gamma 1 phi entails psi, okay. What cutting phi would mean is that you can have gamma 0, gamma 1 entails psi. Now, if you just assume that you have that, and from that you can prove something with the conclusion or a consequent bot, then what that tells you is that cutting phi allows you to deduce bot. And so all those premises together should allow you to prove the phi is paradoxical. So that's the sort of reasoning behind that rule. And then for the elimination rule, if phi is paradoxical, and then in order to prove for this for these delta 0, delta 1 entail psi, in order to prove that, you need to assume these assumption sequence here. Then that means that to get this, that from these two premises, you get to cut phi, but phi is paradoxical. You shouldn't be able to cut it. And so from all of those together, you get bot. Now, as I said, I'm not entirely sure that I think these are entirely right. But one thing I find at least a little bit encouraging is that the situation with respect to Mercy and Rossi's rules is just as it was with LP, which is what you would expect, namely that you can just derive their introduction rule, but you can't derive, at least as far as I can tell, the elimination rule, because the obvious way to do it would require full strength negation elimination, but you don't have that. If you use the weakened version instead, again, you get something, but not enough for their triviality proof. And so to me, again, this sort of maybe suggests, although not as clearly, that there's a kind of, that the notion of unparadoxicality has had cut kind of built into it. Here is a thought to kind of maybe intuitively strengthen that thought, although again, I'm not very sure about it, is just that, you know, if you consider this alternative to their elimination rule, it's one where, okay, if you have that phi is unparadoxical, yes, that does allow you to cut it. But that doesn't mean you can cut out the inference to the fact that phi is unparadoxical, which means you still need it in the antecedent of the conclusion sequence. Now, this means that this is not an elimination rule at all. So I'm not proposing it. I'm merely suggesting it as maybe a way of illustrating how it might be that the idea of unparadoxicality having to conform to cut is being kind of built into the rule. I will say, unlike what I said for K3 and LP earlier, or what I proposed for those, here you do have to start with paradoxical as your primitive. So that is a cost, but seeing as I don't see a good reason why we should have unparadoxical, it seems as the primitive, it seems kind of arbitrary. I think it's a fairly minor cost. Now, the fact that we can't accept Mercy and Rossi's version of the elimination rule means that we can have as a premise that phi is unparadoxical, and yet don't get as a conclusion the result of actually cutting it. And so if you thought that unparadoxical is supposed to express being cuttable, that seems weird. And so I think there's basically two responses you can give. One is to say, yes, being unparadoxical does express being cuttable, but it behaves surprisingly. Another is to say, no, we're expressing unparadoxicality, but not cuttability. Being cuttable is actually just incoherent. So let me kind of go over both briefly. The LP theorists, right, in the response for LP, the response was essentially saying, look, the elimination rule builds in that paradoxicality and unparadoxicality are incompatible, and that's just unmotivated according to LP. And so the ST theorists can say something analogous and say, look, yes, unparadoxicality does express cuttability, but this is compatible with being uncuttable. And so unless you have in the conclusion also, again, that it's uncuttable, you can't actually, as you intuitively understand the term, cut. It seems to me that this is dialectically the analogous move to what I proposed for LP. I find it intuitively sort of a tougher sell than just accepting that everything is unparadoxical. But it seems to me the analogous move, and I don't think it's entirely unviable. The other option is to say, look, just like LP and K3 theorists say that Boolean negation is incoherent, so they don't have to express it. So the ST theorist says, actual like cut is incoherent, so we don't have to express it. You might think, well, what do you mean? We seem to use cut all the time. And again, I think you can just run the same line that K3 and LP theorists usually run about Boolean negation, which is something like, well, we're almost always in classical context. That's why it looks like we're using cut all the time. But we're not using unrestricted cut because that is incoherent. Okay, so in just the last few minutes, I want to go over what I think of as the most important and interesting objection to everything I've proposed. And it is something like, maybe the things I've proposed are on the right track for expressing some generic notion of paradoxicality or unparadoxicality for these target approaches. But Merzi and Rossi have a much narrower and specific notion in mind. And they still can't express that. So all I've really done is change the subject. Now, with respect to this objection, I feel quite differently depending on whether we're talking about paradoxicality or unparadoxicality. So for paradoxicality, I think what Merzi and Rossi have in mind is, again, a much narrower notion than just being paradoxical, but specifically the notion of something like, on the assumption that phi satisfies full classical logic, absurdity follows. Now, you might challenge the thought that we have to express something like this. After all, these non-classical approaches think that expressing full classical logic, all of those rules, having all of them is incoherent. So you might challenge the burden of having to express something like this. I think there's really good reason to reject a move like that. And it is something like as follows, sort of accepting a thought as follows. For any claim of the form on the assumption that we have some rules, A follows, we should always be able to express something like that, even if the rules involved have something incoherent in them. And that is because if we aren't able to express sort of suppositional claims of this form, then we're not able to express disagreement with logics that feature incoherent rules. So consider, by example, a sentence like, on the assumption that the Tonk rules are valid, absurdity follows. I think we do say and have to be able to say that, even though we don't want to be able to express the Tonk rules. So I think that's a kind of motivation for thinking that the kind of suppositional notion of paradoxicality that I think they're asking these approaches to express is one that we should accept. And I think there's a good case to be made that for K3, their rules do express that notion, kind of conditional on full classical logic holding of phi, absurdity follows. I do think their rules express that in a way that what I proposed, which was just not LEM doesn't. So I do think then, I'm sort of sympathetic to that. And I think, again, that for K3, I don't have much else to say other than, yes, K3 is expressively kind of impoverished, and you need an extension of it to be able to express some of these things. So just as you might need an extension to express adequately a notion of paradoxicality in general, you also need it to express the narrower sense that Mercier and Rossi are worried about. And I'm going to skip that. But for AL, I think the matter is a bit different, because I think that this notion of sort of conditional and full classical logic absurdity follows is expressed just as much if you get rid of the multiple discharge from the antecedent of the premise of the introduction rule. And that's what I proposed for AL. So I don't think that that's an extra worry. I do think the rule I propose still satisfies that. For unparadoxicality, on the other hand, it seems like what Mercier and Rossi have in mind is not something suppositional, but something more like just phi satisfies full classical logic. And that, to me, it looks like something we should be skeptical of having the burden to express, because it looks like just expressing full classicality, which, again, according to these approaches, is incoherent. So to the extent we can express something in this vicinity, we should expect it to behave non-classically. If it did behave fully classically, or let's say it this way, let me put it this way, the version of it that does behave fully classically is incoherent. That is the sort of like basic proposal of going for these approaches in the first place. And so I would say, the rules I proposed earlier are at least on the right track for expressing this. It's just it behaves non-classically, and that's what you would expect from going with this kind of these kinds of approaches. And then let me end with what I think is the most interesting and tough objection to the line that I just ran, which is something like this. If you're saying that the sentence, phi satisfies full classical logic, isn't going to behave classically on these approaches, then we're not going to be able to identify the sentence for which recapture applies. So we still have the recapture property holding, but if saying that full classical logic applies to the sentence, if that doesn't behave as you would expect, it doesn't behave classically, then it seems like we're not going to be able to properly identify what the sentences are for which recapture holds, which maybe seems like then, even though you're keeping the recapture property, you're not giving me enough to make full use of it, which is itself a problem. I think that's a really interesting objection, and I don't know exactly what I want to say about it. I think there's sort of two basic categories of response. Maybe there's other things you can say too, but from the ones that are here on the slide, I think the best thing is to go with the first one. If you kind of go to a classical meta language in order to express, to identify what the sentences are for which recapture holds, you're kind of sort of just acknowledging that the object language is expressively incomplete in exactly the way that it was being challenged that it was. So I think that in order for these approaches to have a chance, they have to really kind of bite the bullet and say, look, just the very notion of satisfying recapture is another one of these meta-theoretic notions that we just have to get used to. Don't behave classically. That's just how it is. Okay, there's more I could say, but in the interest of time and letting people ask questions, I'm gonna stop there. So thanks a lot, everyone.